Hello, my dear students. First of all, take care of this contagious disease, coronavirus. I wish you all a sound health. May God bless you all. Today we shall start chapter 1, periodic table. First of all, we should know what is periodic table. The tabular arrangement of elements is called periodic table. Now the question arises, what is the need of periodic table? Our answer will be very simple, that to study about the elements systematically we need periodic table. For example, suppose there are 2000 students in our school and they all are standing on the ground. How one will come to know about each student's class and section? But if they are sitting in their respective classes, then very easily we can say that these students belong to class 8A, 9C, 10B and so on. Likewise, periodic table is also required for systematic study of elements. Many attempts were made to prepare periodic table. Here we shall study about Dobereiner's, Newland's, Mendeleev and modern periodic table. Modern periodic table is also known as long form periodic table. Except modern periodic table. Now we will start Dobereiner periodic table. Dobereiner arranged 3 elements in a triad. Triad means group of 3 elements. He arranged 3 elements in such a way. Suppose it is A, B, C. 3 elements are A, B, C. The atomic mass of middle one means B. It will be the average of atomic mass of A and C. For example, the atomic mass of lithium is 7, sodium 23 and that of potassium is 39. So here sodium is in the middle. This lithium, sodium and potassium are called triads. So the atomic mass of sodium, it will be equal to atomic mass of lithium plus atomic mass of potassium by 2, means 7 plus 39 by 2, which comes 46 by 2 means 23. So atomic mass of sodium is 23. But this law failed to satisfy even within the elements of same family. For example, fluorine, chlorine, bromine are the elements of halogen family. The atomic mass of fluorine is 19. Bromine is 80. So atomic mass of fluorine is 19. Atomic mass of bromine is 80. Therefore, the atomic mass of chlorine should be average of these two, means 19 plus 80 by 2, means 99 by 2, 49.5. But the mass of chlorine is 35.5. So this law failed to satisfy. Now Next is Newland's periodic table. Newland arranged the elements in increasing order of their atomic masses. He found that every eighth elements, from wherever you start, he arranged it as the Indian musical notes like sa, re, ga, ma, pa, dha, ni, sa. He was a great music lover. He arranged the elements in increasing order of their atomic masses. And what he found, that any elements from anywhere if you start, every eighth element, if we start from here, then 1, 2, 3, 4, 5, 6, 7, 8th will have the same property, same physical and chemical property. Now we shall study about Newland's octave law. Newland was a scientist. He was also a musician. He arranged all the elements in increasing order of their atomic masses, and what he found, that every eighth element has the similar physical and chemical properties. For this he was given Royal Society Award, which is called as Davy Model. But this periodic table was accepted only for few days, because this periodic table was not suitable for the heavier elements. Moreover, Newland adjusted two elements like cobalt and nickel. Here, cobalt and nickel in the same place. That's why it was discarded. Then next it was Mendeleev's periodic table. In 1869, Dmitry Ivanovich Mendeleev, he was a Russian chemist. He arranged 63 elements, which were known at that time, in order of their atomic masses. Elements with similar properties were put one after another in the same vertical column, which was named as group. He left some blank spaces and expected that after some time a new element will be discovered whose properties will be very much similar. This was called as periodicity of elements. Mendeleev periodic table is given as physical and chemical properties of elements are the periodic function of their atomic masses. He arranged 63 elements. Actually, while he was preparing, only 63 elements were in existence. We were not knowing about 64th, 65th, and so on. So he divided these elements in 8 groups, like see. These vertical columns are called as groups, and these horizontal columns, horizontal lines, it is known as periods. So he arranged these elements in 8 group and 6 periods. Group 1, group 2, group 3, So these vertical columns were called as groups and horizontal ones were called as periods. So group 1, group 2, group 3, group 4, group 5, group 6, group 7. They were subdivided into A and B, A and B. But group 8 was not subdivided, but he kept 3 elements like iron, cobalt, nickel, radium, rubidium, palladium, like 3 elements. There were some merits. He arranged all the elements known at that time so that the study can be done very systematically. He left some blank spaces. Like if you can see, here is your aluminium. Just here, one blank space is kept. Similarly, just below here, aluminum hit this one, and after some time, another elements like germanium was formed, which has the similar properties. It has some defect also. This law could not explain the electronic configuration. Second defect was argon has atomic mass 39.9, but it is kept before potassium, whose hydrogen has 3 isotopes: protium, deuterium and tritium. Atomic mass of protium is 1, that of deuterium is 2 and tritium 3. So 3 positions should be given, but it has been given only 1 place. This is the difficulty which will be modified. See, when it is modified. Now, there are some features of modern periodic table. If you can see, the modern periodic table has been divided into 18 groups and 7 periods. Group 1 elements are called alkali metals because these metals of group 1, like sodium reacts with water, it forms sodium hydroxide plus hydrogen. Similarly, potassium hydroxide and hydrogen. These are the strong alkalis. So, these are called, the elements of group 1 are called alkali metals because they react with water and form strong alkalis. Similarly, elements of group 2 are called alkaline earth metal because they react with water and form weak alkalis. Therefore, they are called alkaline earth metals. Group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. They are called transition elements. In these elements, they have outermost cell and penultimate cell, means two outermost subcell are incomplete. 13 is called, group 13 is called boron family, group 14 carbon family, nitrogen family, 16 is oxygen family. Now group 17 is called halogens family. Why it is called halogen family? Because in Greek this halogen means salt formers. So these elements of group 17, they react with metals and they form salt. Like magnesium react with chlorine and form magnesium chloride. Since these elements react with metals and form salts, therefore they are called salt formers or halogens. Many times it is asked in the board exam why the elements of group 17 are called halogens. So our answer will be very simple. Since these elements react with metals and form salts, therefore they are called halogens. Now, what is periodicity? The reappearance of similar properties after certain interval of time is called periodicity of elements. But what is the cause of periodicity? The cause of periodicity is the recurrence of similar electronic configuration, means not same, similar. There is some difference between same and similar. Same means identical and similar means something like previous one. So similar electronic configuration means, for example, if you can see, these are the elements of group 17, fluorine, chlorine, bromine, iodine and astatine. They all have the 7 electrons in the valence shell. So they are having the similar physical and chemical properties. Now next issue, metallic characteristic. What is metallic characteristic? Tendency to lose electrons. As the size is small, the nuclear charge and the atomic radii will be very less, so the nuclear force of attraction will be very hard, so removal of electron will be difficult. But as the size increases, this force of attraction decreases and removal of electron becomes easier. So as we can see here, the size is increasing as we move downward. That means tendency to lose electron increases as we move downwards. Means metallic characteristic increases as we move downwards. But when we move across, means left to right, the size becomes smaller, more and more smaller. So removal of electron will be difficult, means metallic characteristic decreases as we move across. Similar will be the case with non-metallic characteristics. Okay, as we move downwards, the non-metallic characteristic decreases, and when we move across, non-metallic characteristic increases. We divide all the elements in 4 classes: representative elements, transition elements, inert transition elements, and inert gases. Inert gases is also called as noble gases. Now we will study all these elements class-wise. Representative elements are also called normal elements or main group elements. There are some heavier elements whose atomic number is more than 20. Many elements which show variable valency, they are present in this type of element in representative elements, like iron. It shows 2 valency, sometimes 2, sometimes 3. Lead, it also show variable valency. Tin, it also show variable valency. Then next type of element is transition elements. It is also called D block elements. What is SPDF block elements? We will study it in class 11. So transition elements include the elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. These elements have the properties that they all have high melting point. These elements have high boiling point. They are good conductors of heat and electricity. Some magnetic elements like cobalt, iron, nickel are in this group. Most of these elements are used as catalyst. What is catalyst? The substance which increases or decreases the rate of reaction but itself do not take part in chemical reactions, like molybdenum, nickel, palladium. These are the catalysts which are present in transition elements. Representative elements. Transition elements have the elements which also show variable valency. Most of the elements of transition elements, they form colored ion and colored compounds. After transition elements, there is inner transition elements. They are also called as F block elements. The elements of 6 and 7 period of the modern periodic table, they are called lanthanides and actinides. They are called inner transition elements. What are their properties? They are heavy metals. They have high melting points, high boiling points, like transition elements. They also show variable valency. They also form colored ions. Actinides are radioactive elements. They are not found in nature. They are prepared artificially. There were some defects in Mendeleev periodic table, like argon has the atomic mass 39.9, while potassium has the atomic mass 39.1. If we are arranging in increasing order of their atomic masses, then this potassium should come before argon, but argon comes before potassium. Similarly, cobalt has atomic mass 58.9 and nickel has 58.6. So nickel should come first, but Mendeleev kept cobalt before nickel. These were the demerits. So now he was Henry Moseley in 1913, who thought that After the invention of isotopes, the same element, same atom of same element has same atomic number but different masses. So he chose the atomic number as basic unit of the elements. And he had given the definition that this is called modern periodic table, invented by Henry Moseley, that physical and chemical properties of elements are periodic function of their atomic number. So what is the basic difference between Mendeleev periodic table and modern periodic table? Mendeleev periodic table was based on atomic mass, while modern periodic table is based on atomic number. But still there are controversy. What should be the position of isotopes? Even the modern periodic table is unable to explain the position of isotope of hydrogen, because hydrogen has. Now next is how the valency changes as you move downwards. Yeah, we move left to right. This movement of left to right is also called as a cross movement. So we shall study about the valency. What happens as we move from top to bottom, means downwards. If we can see, all these elements have only one electron in the valency. Obviously they all will lose only one electron, and that will be its valency, because valency is the capacity of elements. That means capacity of here combining capacity. Combining capacity means the number of electrons lost, gained or shared. This is called its valency. So they will lose only one electron from its valency. Therefore they are called, their valency will be 1. And my dear students, keep in mind, the metals lose only electrons, therefore they are called reducing agent, and the non-metals gains electron, and they are called oxidizing agents. So as we move from top to bottom, the valency remains same. But here now we will come to ionization potential. Ionization potential is also called as ionization energy or ionization enthalpy. See, to lose an electron from an isolated gaseous element, some amount of energy is required. Suppose here is sodium. Its configuration is 281. To complete its octet, one electron should be removed. For removal of this electron, some amount of energy is required. This amount of energy is called as your ionization potential. And after losing electron, what happens about this neutral sodium? It becomes positively charged. So this ionization potential is what? The amount of energy required to remove an electron from a neutral element to change it in positive ion. This type of definition should be kept in our mind for the point of exam. Many times we are asked in board exams. Now, when we go downwards, now when we move downwards a group, the size of an atom increases, atomic size increases. Higher is the size, more will be the distance from nucleus, and less will be the force of attraction. As a result, the removal of electron will be easier. Removal of electron will be easier, means less energy will be required, less ionization potential will be required. It means that as we move downwards in a group, ionization potential decreases. But if we move across a period, we can see here the atomic size is decreasing and decreasing. As a result, if the atomic size decreases, means force of attraction increases. As a result, the electron's orbits comes close to the nucleus. So removal of electron becomes difficult. Means more energy will be required. For this, more energy is required. For this, more and more energy will be required. So ionization potential increases as we move across. Next topic is our electron affinity. It is also called as electron enthalpy. When a neutral atom gains one or more electron, it becomes negatively charged, means it forms an ion. As we know that chlorine has 287 electrons. This chlorine needs one more electron to complete its octet. So after gaining one electron, it becomes negatively charged. But as it gains one electron, it forms an anion plus some amount of heat energy is produced. This heat energy produced is called electron affinity. So now what is electron affinity? The heat energy produced when a neutral atom gains one or more electron and change to negative ion. So this heat energy produced is called your electron affinity. Electronegativity. Here is a chart. Different elements have different powers to attract the shared pair of electron towards itself. If we move downwards, hydrogen has 2.1, lithium 1, sodium 0.9, potassium 0.8, and so on. So this power to attract the shared pair of electron decreases as we move downwards. Means electronegativity decreases as we move downwards. Now if you see, if we move across here, lithium has 1, beryllium 1.5, boron 2, carbon 2.5, nitrogen 3, and so on. So this electronegativity value increases as we move across a period. Now question arises, what is electronegativity? So electronegativity is the tendency of an atom in a molecule to attract the shared pair of electrons toward itself is called electronegativity. Simply we can say electronegativity is the tendency to attract the shared pair of electrons towards itself. Means both the atom should attract the shared pair of electron toward itself. As I told you earlier, if the atomic size increases, means if greater is the size of atom, greater is the size of atom, less will be the electronegativity, and if greater is the nuclear charge, greater will be the tendency to attract the shared electron, means greater will be the electronegativity. Atomic number. Atomic number is the unique property of an element because no two elements have the same atomic number. It is denoted by Z, capital Z. Atomic number is the number of protons present in the nucleus. It is called atomic number. An atom is always electrically neutral. Why? Because they contain same number of protons and electrons. That means in any atom, the number of electrons and number of protons are same. So we can also say that atomic number, it is the number of electrons present in an atom. But normally we define in the terms of protons. Mass number. In an atom, the positive charge means protons and neutrons are present in the nucleus. So sum of these protons and neutrons is called mass number. For example, sodium has 11 electrons. Its configuration is 283. 11 electrons means it will have 11 protons too. Its atomic number will be 11. Calcium, it has 2882, 20 electrons. Means it will have 20 proton also. So atomic number is 20. Similarly, calcium has 20 protons, its atomic number is 20, but mass number, it has 20 neutrons in the nucleus. So mass number is 20 proton plus 20 neutron means 40. Like sodium, sodium has 11 proton and 12 neutron in the nucleus. So its atomic number will be 11 and mass number will be 23. There are some differences in the elements. First of all, number of cells. If we can see, as this is the elements of group 1. These are the elements of group 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium. So as we move downwards, the number of cell increases by 1. It is not so that sometimes it increases by 1, sometimes by 2, sometimes it remains same. No. As we move downwards, the number of cell will increase by 1 only. As a result, atomic size will increase. Obviously, if the number of cell increases, the atomic size will increase. But When we move from left to right, we can see here these are the elements of period 3. As we move across, the number of cells remains same, but atomic size decreases due to the increase in nuclear charges. Now, what is nuclear charges? The number of positive charges present in the nucleus is called nuclear charges. Now, we will do the comparison between alkali metals and halogens. On this basis, elements. What are the elements of alkali metals? The lithium, sodium, potassium, rubidium, cesium, and francium are the elements. They are the elements of alkali metals. Means they are alkali metals. Now, how do they occur? They never occur in free state. Why? Because they are very reactive. Therefore, they are found in the nature in combined state. Similarly, the halogens, the elements of group 17, elements are fluorine, chlorine, bromine, iodine, and astatite. They are also very reactive. Therefore they are not found in the nature in free state, but they are found in combined state. Then, physical state. These alkali metals have white shining colors. They are soft. Sodium and potassium are so soft that they can be cut by knife. Among these metals, lithium is the hardest. All alkali metals are their metals. Halogens, they are nonmetals. All these halogens have atomicity 2. Fluorine is most reactive. Its color is yellow. We should know the color of the chlorine, either yellow or greenish yellow. Then, valence electron. All alkali metals, if we see the configuration, they all have one valence electron. And halogens, all the elements of halogen family has 7 valence electron. Melting point. For alkali metals, as we move downwards in a group, the melting point decreases. But in the case of halogens, it increases. Atomic size. As we know that if we move across in a period, the atomic size decreases. So alkali metals are the first element in any period. Therefore, alkali metals have the largest atomic size, which decreases as we move across and increases when we move downwards. But halogens have the smallest atomic size, and it increases as we move downwards. And potential. All alkali metals have low ionization potential, but it decreases as we move downwards. Ionization potential means energy required to remove an electron. Since the atomic size increases as we move downwards, force of attraction decreases. As a result, removal of electron becomes Eg, means ionization potential decreases as we move downwards. But here in the case of halogens, they have large ionization potential, and this ionization potential decreases as we move downwards in a group. Electron affinity. All alkali metals have low electron affinity value, which further decreases when we move downwards. But halogens, they have high electron affinity. Like alkali metals, the electron affinity value of halogen also decreases when we move downwards. Electronegativity. They have least electronegativity, which decreases if we move downwards. But halogens have high electronegativity and it decreases if we move downwards. Reactivity. Alkali metals are very reactive and its reactivity increases as we move downwards. But halogens are very reactive elements, but their reactivity decreases as we move downwards. Reaction with water or acid. So they react very fastly with water, producing hydrogen gas. And halogens, normally they do not react with any acid or water. Reducing agents or oxidizing agent. Since alkali metals are the metals and metals lose electron, I had told you that the elements which loses electron are called reducing agents. So all the alkali metals are strong reducing agent, while halogens, they gain electron to complete its octet. So all the halogens, they are strong oxidizing agents. Now we will study about the different types of elements. First, it is representative elements. Representative elements are also called normal elements or main group elements. The elements of group 1, 2, 13, 14, 15, 16 and 17, they are called representative elements. Now, what are the properties, what are the characteristics of representative elements? These elements are metals and non-metals. There is a regular variation from metallic to non-metallic characteristics. Variation means as we move across, the metallic characteristics decreases. They form covalent compound as well as electrovalent compounds. Like sodium is a metal, chlorine is a non-metal. Sodium and chlorine combines and form sodium chloride, which is an electrovalent compound. Like HCl, hydrogen chloride, or hydrogen chloride gas, or hydrochloric acid. Hydrogen is non-metal, chlorine is non-metal. Both non-metals combine and form HCl. So these elements, can form electrovalent as well as covalent compounds. Their metallic characteristic increases on moving down. These metals are good conductors of heat and electricity. Then it comes inert gases. Inert gases are also called as noble gases or rare gases. These gases are the elements of group 18. Group 18 is also called as zero group. There are 6 elements in this group. Means there are 6 inert gases like helium, neon, argon, krypton, xenon and radon. Except helium, other 5 elements have 8 electrons in the outermost shell. Helium has only one shell in which there are 2 electrons, so its duplet is complete. And neon, argon, krypton, xenon, radon, their octets are complete. They never react with other elements, therefore they are called inert gases. Now, bridge elements. What is bridge elements? The elements of second period. Mind it, elements of second period show some similar property with the elements of next group of the third period. This relation between the elements of second period with the elements of next period and next group, they are called bridge elements. If we can see, lithium is the element of period 2. It shows some similar property with the elements of group 2, period 3. Beryllium is an element of group 2, period 2. It shows some similar property with the elements of group 13, period 3, aluminium. So they are called bridge elements. And the elements of third period are called typical elements. Now it comes typical elements. What is typical elements? The elements of period 3 are called typical elements. There are 8 elements in the third period. They are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. We should keep these elements in our mind for the point of exam. Many times it has been asked that what are the elements of period 3 or what is typical elements. So we should summarize it. It is very easy to summarize.